Okay, so rational still basically means fractions, and so if we're solving rational equations, we're trying to solve equations that have fractions in them. So that's what all 10 of these questions have in common. It said there's a bunch of fractions. Now, we do have to be careful about extraneous answers as well, so talk about that in question 4. But basically what it amounts to is if I ask you to solve this, or if I ask you why this seems to be harder to solve, most of you would say that it looks harder to solve because of the fractions. Well, if that's the case, then let's take a step or two and get rid of the fractions. So obviously we can't just ignore them. We can't just pretend like they go away. But what we can do is we could say between 2, 3, and 6, if I multiplied them all by 6, all of the fractions should go away. Now you've got to multiply everything by 6, every term. The reason why that's okay is because now it's like I'm multiplying the left side of my equation by 6, and it's like I'm multiplying the right side of my equation by 6 and distributing. So you can multiply one side of an equation by something as long as you multiply the other side. It would keep it balanced. So it's kind of like complex fractions. Now we know those divide away. This reduces. This reduces. And we're not finished, but what we're left with at least isn't fractions. So I multiplied this one by 6, that canceled out. I multiplied this one by 6, 6 over 3 reduced to 2. I took that 2 and multiplied it by the 2a that was already there. I multiplied this one by 6, it reduced by 2. 6 divided by 2 gave me 3, and I multiplied that by the 1 that was there. And then usually once you do that, it's not too bad to finish it off. So isolate your variable. Undo the plus 3 with minus 3. And finally, I do times 2, divided by 2. And it looks like negative 3 is our solution. Now, unfortunately, with most of the stuff we've been doing recently, it's not the ones that we can check. This is a little harder to plug in our calculators to all the fractions, but we can still check this. I stored negative 3 for A. The left side is equal to something. I don't really care what it equals to. I do care that it equals the right side. So left side equals right side. I'm 100% sure this is correct. Okay, so other than the denominators getting a little messier, so one way they can get messier is we're going to throw some variables in there. And then the other way is you need to factor the denominators as well. Okay, so this one, I was not worried about extraneous answers, and this one I am. So let's set a little side here, and we'll refer back to this at the end of the question. Okay, there's two solutions that are not possible, regardless of what the algebra tells us in the end. K cannot be 0. If I plugged in 0, that gives me division by 0 there. And K cannot be negative 2. Because if I plugged in negative 2 here, it gives me division by 0. And we can't divide by 0. So regardless of what the steps tell me, in the end, if I get an answer of 0 or negative 2, I cannot include those. Those would be extraneous. Okay, but we might think of this as a fraction, put this over 1. And so I want to figure out what can I multiply by to make all of those denominators go away. Because we saw if we did that, it was pretty easy to solve after that. Okay, well, if I multiplied everything by k, it would make those cancel out. If I multiplied everything by k plus 2, makes those cancel out. And you can see, like many things we've been doing lately, your work can get very messy very quickly. So be careful with that. We've got 5x times x, or 5k times k. We've got 2 times k plus 2. And on this side we have 5 times k times k. And 5 times k times 2. Not that this will always be easier, but at least this is stuff that we've done. That first step or two in there is the only new thing that we have. So it looks like a quadratic. I guess there's a small chance we might need to factor a quadratic formula. But subtracting 5k squared to make them go away from both sides. So looks like we're not going to have to do that after all. And then a step or two later, looks like we get k as a half. Now, I had to think about this before I circle my answer though. Regardless of what this says, if I got k equals 0 or k equals -2, I could not have included those answers. They would not solve the original equation. Okay. So you don't have to hope these are correct. You can take a moment and score in what you think the answer is, and you can try to check it. Notice these are a little bit harder to plug in, so you do have to practice if you hope to do it on an assessment. Okay, so doing that, the left side equals 5, the right side equals 5, the left side equals right side. So I'm 100% sure that answer is correct. So look at number 1 as an example. It just had numerical denominators, so we only had to multiply by numbers. That's what question 2 looks like. So you don't have to finish the question, but I want you to try the first step. Rewrite that so that it is equivalent, but does not have fractions. Try the first step of getting rid of the fractions. So you could have multiplied everything by 2 to get rid of this denominator specifically, and then multiply everything by 7 to get rid of this denominator specifically, and then you would notice you had everything here. Or, if you want to do it in one go, everything needs to be multiplied by 14. And it is important to me that you understand why this is okay. Because if you don't understand that, you're not going to remember that this is okay to do 6 months from now or 2 years from now. I'm essentially multiplying the left side by 14, distributing it, and the right side by 14. And it's fine to multiply one side of your equation as long as you do it to the other side. That's all we're basically doing. So this one reduced to a 2, this one reduced to a 7, and this one is completely canceled out. So I wanted to see if you got 4b minus 6, because it's 2 times all this stuff, minus a 7b. Make sure you didn't overlook the minus sign. Equals b plus 3. Alright, and if you get to this step, I'm not really too worried about you. You need to finish it. Add 3b's to both sides, subtract 6 from both sides, divide both sides by 4. Answer looks kind of funny, but we can plug it in and check. I think this is my answer. There's the left side. Here's the right side. I don't care what the left side equals to. I don't care what the right side equals to. I just care that they're equal. I care that as if the same thing equals something. So even though my answer looks a little different there, I'm still not concerned about it. Perfectly fine. Okay. Number 5 looks a lot like question 4. So same thing. I'd like you to try the first step. Look at how we got rid of the fractions in step 4 or question 4, and you try to do that on question 5, and then we can finish it together. So if this one has a factor of m plus 1, and this one has a factor of m minus 1, you need to multiply everything by both. This one needs to be multiplied by m plus 1, m minus 1. Part of it cancels out. This one needs to be multiplied by m plus 1 and m minus 1. Part of that cancels out. And make sure that you did this side too. If you only did these two, it's like you multiplied the left side and not the right side. So whatever answer you get would be to a different question. Every single term. Even if it's not written as a fraction, because you can put it over 1 and make it a fraction. Okay, so if you did that correctly, I want you to see, did you get m squared minus m plus 5 times this, which would be 5m plus 5 equals, and then if you multiply this stuff together, m squared, those are conjugates, so the outer and inners are going to cancel anyway, so I'm going to skip that part and that. So once you get to this step, it can be as simple as a 2-step algebra 1 type level equation, or it could be even a quadratic, where we have to get a quadratic formula in the worst case scenario. And that is stuff that we've done before. We subtracted an m squared from both sides, those go away. So I can tell that quadratic formula is not going to be necessary here. Subtract 5 from both sides, and divide both sides by 4. And that reduces, so we need to reduce. I'm pretty sure that's my answer. Obviously, I can use my calculator to check. But again, we have to force ourselves. Even though this may not happen much, there are some answers we could not have accepted. M could have never been -1, because that would have made this division by 0. Also, M could never have been +1, because that would be division by 0. Regardless of what the algebra says, if we got an answer of 1 or -1, it would be incorrect to include it. It would be extremes. For extraneous is where our math logic's good, our arithmetic's fine, it didn't do anything wrong, just doesn't solve the original equation. Nothing about the original equation is unusual. For example, certain values just can't be plugged in because they need a division to do it. If you're willing to plug it in and check it each time, you don't have to worry about that, because if you try to store -1 in and you check this, it's going to say error, division by 0. It's going to know something's wrong with it. So one more time, how to check it. It's always a good idea to put parentheses around the numerator and parentheses around the denominator. Sometimes it's not needed, but sometimes it is. And that's what I get for the left side. The right side was already 1, so the left side equals the right side. I don't have to waste any more time on that question. That worked out. Okay, so questions 2 and 5, I finished off for you. I just asked you to try the first step. I now want you to try from beginning to end, question 3 and 6. Think about what you need to multiply by. Think about what answers you could not keep that would be extraneous. Try to plug it in your calculator and store it and check it to make sure that it actually works. And I will go over both of these after you've had a chance to check them. I'd like to do one more example for you on the back page. But the other 3 in the back page are going to be on your own. Putting those in, and it's all working out fine. We need to move on to that. So I've asked that you go ahead and check your answers by storing it into the calculator. So if you know you got these two right, again, you can tune me out here for a second and just continue working on the back. But if you didn't check your answers and you're not sure if it's right, or you got stuck and you're not sure what you should have done, then it's going to be more beneficial that you follow along with it. So between 2 and 5, we're going to multiply everything by at least 10. You can multiply by more than that. You can multiply everything by 20 or 100 or 1,000 if you wanted to. Because you're going to have some unnecessary simplifying if you do that. Try to get away with the smallest thing possible. And you have to multiply everything by an x. Otherwise, you're not going to get rid of that half denominator. So 10x divided by 5x would be 2. 10x divided by 2x would be 5. And 10x divided by 1, nothing cancels. So you've got to multiply these two, and multiply those two. And it looks like 41 is 10x, so x is 41. Make sure that that's an okay answer. I did not plug in 0, because that would make the denominator 0, and I could not have put in 0. That would have been extraneous too. So regardless of what this says, I have that 0 as an answer. I cannot have included it. So 41 tenths, store it. That is 3 over 5x plus 7 over 2x. That's the left side of the equation. So I hope that this equals 1, because then it would be equal to the right side of the equation. It does. So everything's fine. Okay. Number 6, you wanted to multiply this one by 3x minus 2. Make those cancel. But then this one gets multiplied by 3x minus 2. And this one gets multiplied by 3x minus 2. All or none. This one, you wanted to multiply by 3x plus 2. Make those cancel. So this one also gets it. And this one also gets it. Okay. And so in all of that mess, right here, you've got 4x times 3x plus 2, which should have given you a 12x squared plus 8x. With these two canceling, this should have given you a 6x squared minus 4x. And then this is, I could do this in one step. 2 times, if I FOIL these are conjugates, so I know the outer and inner are going to cancel out anyway. Okay, so the right side, after you distribute that 2 and FOIL, that stuff looks like it's equals to 18 x squared minus 8. So if I start to combine this stuff together as well, subtract 18x squared from both sides. You're left with 4x equals negative 8. So x equals negative 2. That is constant the same in that. Could still be wrong. It makes this denominator 0 or that denominator 0. It does not happen here. We have to check it every time, otherwise we're not going to catch it when it's necessary. And there's a handful of places I could have had a careless arithmetic mistake, so the extra 30 seconds to check. Here's the left side, the right side is 2, left side equals right side. Store just fine in the calculator. If you need help with the story, please let me know sometime today, because that makes it a lot easier than trying to type in -2 in all those places. Alright, so there's 4 questions on the back, and the one I want to do one more with you. And I'll give you 2 minutes to try the others. That's question 10. So that's kind of a similar trick to other things we've been doing with adding and subtracting rational expressions and the complex fractions. But I can see I obviously want to multiply everything by an x minus 2, or k minus 2. definitely want to multiply everything by k minus 6. Those are just a little bit easier to see because those are already factors. You can multiply everything by k squared minus 8k plus 12, but it is going to be much harder to simplify correctly. So instead, do yourself a favor and think about how these factors and more often than not, it's probably been rigged where some of this has already been multiplied for you, if not all of it. In this case, I was already wanting to multiply by k minus 6, and I was already wanting to multiply by k minus 2. So that works out great. If it's not factored, you should consider factoring. It will greatly simplify. It's much easier to simplify at the beginning than it is at the end. So if you do that, the only thing left on the left side is a 4. Over here, this is a k squared minus 6k. And over here, this is a k minus 2. This one doesn't look quite as easy because the quadratics didn't just magically go well like they did on the front page. But if I'm trying to solve a quadratic, remember we want it to be in standard form, which is equal to 0, so subtract that 4 over. And then you've got a handful of ways to solve this. So if you have a calculator, I guess you could solve it with graphing, quadratic formula, because it always works. And in this case, this one also factors, which is my preferred method just because it's quick. And so this times this is supposed to equal 0. That's true where this equals 0 and where this equals 0. 6, negative 1. Good with both those? So I'm not going to do anything wrong here, but you can't plug 6 in right here because it gives you division by 0. That is an extraneous answer. Just one of those things you have to force yourself to check. It's got to be part of your habit or you're not going to do that. Negative 1 can be plugged in here. It doesn't make the denominator 0. It doesn't make this denominator 0. It doesn't make that denominator 0. So negative 1 should be fine. But of course, you can plug it in and check the calculator if you absolutely sure. So let's talk about the plan for the rest of the class.